because of OneDrive, and now this video from YouTube will not play. I want to show you how we test this kind of concrete. And I think it's worth the wait for my computer to connect. I hope. Let's see what happens. This is annoying. Okay, then I will have to just explain it to you, because now it all just froze. Let's just try to move ahead. Okay, I will have to explain it to you. I will load up the video later and maybe we can watch it in a break or something. What we do, how we test it, because there is no test method, there is no standard for this kind of thing. So we mix the concrete or mortar, we fill it in a little plastic cup, and then we flip the cup upside down on a sieve, just a standard sieve for sieve analysis of aggregates. And we move it, let's say 5 times back and forth. So we have a kind of a simulation of the same effect as in the vibropress. We are trying to get the concrete through the holes of the sieve, and we catch the concrete that falls through, and we measure how much gets through. And basically, the more we can get through the sieve, the better. It's kind of stickiness of the concrete. I call this fillability. It's a mouthful, but it's I think it describes it quite well. And basically, more better. More of the concrete we can fill through the sieve, the better, or in the vibropress. Depending how we set the reference, that's why there are no numbers, but generally I try to set the reference to get around 20% of the concrete through the sieve. So that's this. And we noticed that the existing products, the Hydrotech 15 and 16, help. They help a little, but they help. But it's not enough. 15 a little bit more than the 16, but it's just a little difference. With the 860, we can really get much more through the sieve. The concrete visually, when you mix it, it doesn't look any different. It's semi-dry, you don't see it, but when we do this test consistently, we can see an improvement. And there is a product in the market from Sika, which is exactly the same thing. As usual, this product exists already for a year or two. And we can see in our lab the performance being almost identical. So I think we have basically the same thing. Compaction is fine. It's not as good as the 16. Not many products are as good as 16 in compaction, but it's good enough. It definitely is more than the reference concrete, and therefore also the strength is improved. So basically now we have a product that allows us to produce more consistently. Could actually be interesting going forward for the new cements with the dusty, lower quality sands. When we have much more fines in the concrete, we need to put in more water, it all gets more sticky. I think this is something that could really help in the paver production. I try to kind of categorize these 3 main properties of compaction aids, which is density improvement, strength, and this new fillability property on a scale from 1 to 3, just so we can see how this works compared to the existing products. 1 doesn't mean it's bad. 1 just means it's the least better. Yeah. So it still improves density, just not as much as something else that would have 3.0. Important to mention, but because I think it could be misunderstood like this. The product is not finished yet. It's still a test product. It's called XP, blah, blah, blah. That's how you can order it. I don't want to bring it to the market just yet before we get some real experience, because I have been burned like this few times. When I make a product, I make the data sheets, everything, and then after 1 year, the sales are this much. So I will wait a little bit, test it in the market, but we are stocked up on the raw material. We can do factory tests next week. So let me know if you are interested. The price will also be very pleasant, I think. The final calculation will be done when the product workflow is finished, but based on the raw material cost, we should land in this under 40, maybe 35 cents ICP. 0.5%, something like this. No, 0.5, the normal kind of percentage. What do you mean? I mean, that has to be evaluated. That has to be evaluated on case-by-case basis. But what we are offering is the ability to produce on the more consistent quality. It depends on the customer, on the concrete. So there is not a what we can say. This is a 15% cost savings every time. There is some, of course, but I cannot put a number on that. Of course it is. But I mean, you mean in this in the sales price? You mean? In the concrete goods, the pressure on the prices is so low that we don't really have much place for like this kind of marketing prices. Look, this is the Bottrop ICP. So there we are not making any extra money because it does this or that. This is just the standard ICP calculation. The price, of course, if we sell this for €1, which I think is imaginable, then I think we can have a nice margin here. So to hurry up a little bit, this is not as exciting, but it is definitely something. Hydrotec 15, BWA 15. You know the product. Most of you don't sell it because we sell a lot of it to one customer in Germany, a very big one, but one. Last year, the supplier decided to stop the production of the main raw material because I think he also had only one customer for this product, which were us. And I said, sorry, we will not be selling this anymore because it's not worth to produce. So we had to look for alternatives. And we did find an alternative, surfactant, a tensite, which is better than the current one, which is very nice. So when we do the comparison on the gyro compactor, we achieve better density. And interestingly, the strength increase is higher than the density increase, suggesting that there is something else going on, like less air entraining or some kind of better cement distribution activation during mixing. So very, very interesting update for an old product. But what's even more pleasant than the gain in performance is that the price stayed the same. So the raw material is not more expensive. So we can really now have something that's better, but not more expensive. And on this scale that I created, this is kind of a middle of the road product. It helps with the density, it helps with the strength, and it helps with the filling. It's not as good as 16 here. It's not as good as the new 860 here, but it's kind of a good jack of all trades. And finally, when I plot this visualization across all our products, or the main ones, you can kind of see why I did that. So it's hard because it's all very similar, very, very watered down products to really explain to people why this one is better than this one, or what does this do over another. So now in the surfactant field, which is for pavers, for hollow core blocks, kind of for the mass-produced concrete goods with less cement, the surfactants are better, generally also cheaper. We have one that's extremely good for the strength, for the compaction, for the density, but it can lead to a little bit of a sticky concrete, or it doesn't create sticky concrete, but it doesn't fix the stickiness. So if the customer has a sticky concrete and you offer him the 16, he will still have a sticky concrete. The middle stones will be better, more compacted, but the side stone will still be shit. He could try the 15, which will help. Side stones will get better, the middle stones will get more optimized, or even the 860, which will just go all the way for the filling. So depending on what is the situation, what is the mix design, and again, this has to be evaluated on a case-by-case basis, but we can do that. We now have a really broad options. F is fillability. Yeah, that's when I was presenting this in Germany, I had the F here because Festigkeit, so now it's fillability, Befühlbarkeit. So plasticizers, just to sum it up, they don't help at all with the stickiness. They can actually make it worse because the PCE molecules are big and there is not much water in the concrete. So unless the customer knows what they are doing, there are some that use PCEs for pavers. Don't use PCEs for pavers. But for something like pipes, pre-stressed slabs, bigger concrete goods,